All right, we're going to look at 1.4 today, which is switching from inductive reasoning to deductive reasoning. And I know I've alluded to it before. What's the difference between the two? So let's look at an example to illustrate it. John's come up with a conjecture. He says that whenever you add 5 consecutive digits, you will always get an answer that is 5 times the median of those numbers. So first of all, I see a word there, median, from statistics that you've done before. And median means the middle number when you arrange them from greatest to least. So I'm going to look at this third example here. And if you look at the median number, the number that would be in the middle of 5 numbers, that's -5. And he's saying times that by 5, you'll always get that. Let's check the previous one. Times that by 5, you get that. Times that by 5, you get that. This is using inductive reasoning. You are collecting evidence and making a conjecture based on that evidence. Today, what we're going to look at is how do I prove that for all numbers? So let's take a look at an example of something you can do. This person decided to let x represent any number. And then s represents adding all those numbers together. So if x is my number, and I'm talking about 5 consecutive numbers, I could talk about the 2 numbers before x, which would be minusing 1 and then minusing 2. And then the numbers after, which would be adding 1 and adding 2 together. And when you simplify that, just adding x's together, you get 5x. And the numbers added together, -2 and -1 and 0 and 1 and 2, they add to 0. So no matter what, you're getting an answer of 5x. Whatever the middle number is, in this case, that number is being x. The answer will always be 5 times that number. And so, using a deductive proof, which means to show it for all situations, John has shown the conjecture is true. So here's some definitions for you. You're going to want to either write them down from here, or you can look in your textbook and write them down. What you want to be able to do is, again, be familiar with these so that when you're doing assignments that you are fluent in the language of mathematics. So let's take a look at another example. All dogs are mammals. All mammals are vertebrates. Shaggy is a dog. What can be deduced about Shaggy? Deduced meaning what's a generalization that you can come up with. To deduce means to come up with a conclusion, a firm, absolute conclusion. And to do that, it's helpful for us to draw what's called a Venn diagram. And so I'm going to draw a circle here, and I'm going to say that with the situation here, we have dogs are mammals, and then all mammals are vertebrates. So let's let this circle be vertebrates. No, that doesn't make sense, does it? Actually, I think I was right. Let's go with vertebrates in here, which includes all mammals. Sorry for my messiness here. Within that group of mammals are dogs. And we're told that Shaggy is a dog. If Shaggy is a dog, what can we deduce for sure? Well, there's dog circles within the mammal circle, so this dog is definitely a mammal, and all mammals are vertebrates, so we could say that Shaggy is a vertebrate, for sure. And all the Venn diagram does is allows you to visualize that. Let's consider another one. Weightlifting builds muscle. Muscle makes you strong. Strength improves your balance, and Inez lifts weights. What can we deduce about that? So again, if we use a Venn diagram, we've got muscles. And with muscles comes strength. In order for you to have muscles or strength, you could have those. One way would be weightlifting. If strength improves balance, Inez lifts weights. What do we know about Inez? Well, weightlifting builds muscles. Muscles make you strong. Inez lifts weights. So weight, lifting weights, pardon me, it leads to muscle. Muscle leads to strength. Strength leads to improved balance. What can we do about Inez? Inez must have improved balance, according to that logic. There are also deductive proofs involving geometry, and this is an example of proving that when two straight lines intersect, the vertically opposite angles will be equal. So when we look at this situation right here, we have a proof that's called a two-column proof. We have one side statements, the other side's justification. We have some angles involved. Angle AEC, angle AEC is right here, and angle AED is right here. We know they make a straight line, so they add to 180. And then rearranging that, which is called your subtraction property, or pardon me, subtracting a common angle from both sides, being minus, or pardon me, angle AED, allows us to rearrange it. And we can do the same thing with angle BED, which is right here. Whoops. Which is right here, saying that that angle plus the angle AED adds to 180. And, oh, sorry about that. That's a little crazy. By the subtraction property, we can say that, again, we have two things that end up equaling the same thing. That if angle AEC equals 180, subtract that angle, and this angle also equals the same thing, that these two must in fact be the same, and they are what are called vertically opposite angles. If you look at the X that is created by the two lines, they are on opposite sides. Angle AEC, which I pointed to there, and angle BED, which again is right here. They must be the same. When you say that one thing equals another because they both equal another thing, that is called the transitive property. And again, there's some more definitions here for you that you might want to write down at some point. Your job is going to be to use them and sort them out so that you will find success, because I can't do that for you. So here's a question that we could do. We're just going to skip right over that, and we're going to jump right to the assignment here. Here's a summary. It's in your textbook right before the assignment. Here's your assignment. Your job is to work on it in class and to ask questions as you work, to sort it out. As I said before, I can't learn for you, and I need you to work your butt off so that you find success. That's it.